Hi, boys and girls. We start our lesson today. Okay, that day we stop at lesson number 20. Have you guys tried? If not yet, then we try it together right now. But if most of you try already, actually we can do much more faster lah. Okay, boys and girls, a trolley runs from P to Q. This is page number 7. That day we stop at here. Okay, question number 8. Now we goes to question number 9. It's talking about energy. Okay, we know that energy cannot be created, cannot be destroyed. It can only transform from one form to another form. So at here, we need to identify as starting what is the energy, and ending what is the energy. In perfect case, starting and ending energy must be equals amount lah, because we cannot lose what. Okay, but in reality, some of the energy may be lost to the surrounding because of friction. So at here for this question, they say that at Q, the potential energy. Okay, why got potential energy? Because this is the ground part. Okay, where here? Here, let's say here is the ground. Okay, somewhere here lah. Okay, from here to the ground, it still have certain position. So for Q, we still have GPE. Okay, this GPE actually I write in GPE lah. E. Okay, in GPE. At this position Q, the energy for GPE actually will be less than the P position. So minus 50 kilojoule. Okay, less than, because it's not that high what. Okay, so this one higher, this one not that high, so the GPE actually less than 50 kilojoule. Okay, this is the first sentence it tell you. So at here, this one is the energy GPE at point Q. Okay, at point P. Okay, at point P. So at here, at P kinetic energy. So that means that they told you that not only have GPE, but it also have kinetic energy. Okay, for point P is also have kinetic energy is 5 kilojoule. Okay, between P and Q, the trolley does 10 kilojoule of work to against friction. So at here, they got friction. This friction, it will produce like heat energy. So we will having some energy lost to the surrounding because of this friction. Okay, lost to the surrounding with 10 kilojoule. Okay, what is the kinetic energy at Q? So at here, we also have kinetic energy at Q. Okay, boys and girls, can you try? If you haven't tried, can you try? Then you type your answer in the chat box. You have to type to the Newton Scholar chat box, so that I can see. Because the Dr. Low account actually is my iPad. Okay, like boys and girls, you try for this question number 9. Starting, what is the energy? Final, what is the energy? But the final is not the real amount, because some of the amount is already lost to the surrounding. Okay, so at here, try it and then tell me your answer. Energy total in point P must be energy total in point Q. But don't forget there is some friction. We need we need to do some work to overcome friction. Right, boys and girls, do it. Although we don't know what is the energy for GPE at point P, but actually at the end you move here and there you can cancel. Okay, now waiting for your answer. I already got you. Try. Prasan, correct. Prasan, you already did it, or right now you only do? Already do. Good job. Tony, can try one more time? Washini, correct. Fawal, correct. How about others? Let me check. Joreen, no, Joreen. Later on check why you cannot get the answer. No, Joreen can try one more time. How about others? Okay, Vashini is correct. Right, boys and girls, see here. This one is at start. I have this energy, GPE and kinetic energy. Okay. Then after that, at E position, I have GPE, but this GPE minus 50. Okay. Lower than 50 joule than the just now at P. Then I got kinetic energy because they're asking us to calculate the kinetic energy. Then this amount actually not equals to the initial because some of the energy is losing to the surrounding. So we should plus the 10K. Okay. So at here, basically the GPE and GPE, you move here and there, actually you can cancel out lah. Okay. So what is your energy? For your kinetic energy, actually it should be the 5K plus 50K minus 10K. So actually you should get 45K. Answer should be B. Okay. Those who choose C, you have to think, oh, is it you forget about the 10K? Is it you forget about the 10K minus 10K? Okay, check. Okay, boys and girls, if no question, everything okay? Can you give me response? There is one button at there beside the chat box. Participants, chat, and then react. So you can react and I will know. We can proceed. Okay, thank you. Like boys and girls, we go to page number 8. Okay, here. Okay, an object is thrown vertically upward. So we throw vertically upward from the ground with initial velocity 8 meters per second. Okay, the object will reach a maximum height. So at here, maximum height. Maximum height is actually 1.9 meter. How much work is done to against air resistance as the object rises to its maximum height? Okay, so at here you have to think, starting what is the energy it have? Okay, starting what is the energy it have? So you have to do calculation about here energy. This is velocity. So you got velocity, initial velocity. Of course, it will have kinetic energy. It will have kinetic energy. Then after that, go up. Go up, what energy you will get? Can you see that keyword? Rises. Okay, if they rises, that means that we are going to have certain position. So this one is your GPE. You will get GPE. Okay, so you go up, you got GPE. But do not forget, they got air resistance, so which means that some energy will lost to the surrounding because you need to do extra work to against the air resistance. So at here, in between here, surrounding, actually you got work done to against air resistance. Okay, the idea is here. Starting kinetic energy, some of the energy lost to the surrounding because we need to against air resistance. Then at the end, we achieve the certain position. So we gain GPE. So can you, based on this information, try to do your calculation? Prasan is good. Prasan already complete, so he already get the answer. Answer is correct, Prasan. Prasan, actually, lesson number 22. Lesson number 22 is self-practice. If you already print out, actually, you can try with the self-practice question. Vashini, correct. Vashini, correct. How about others? Jore, correct. Fawal, correct. Tony, correct. Yes, that means that okay, everybody okay? So at here, starting at here, we got 1 over 2 mv square. Final at here, we got mgh. So 1 over 2 mv square equals to mgh. But don't forget, we spend some energy in overcome the air resistance. Okay, so 1 over 2, the mass 0.3, the velocity starting is x squared equals to 0.3, 9.81 times the height is 1.9 plus the air resistance. So you just apply this concept. At the end, you should get 4 joule. You see, there, if this one is not MCQ, it's the paper 2 for us to write and we show the working step. Actually, if I write 4 joule is not a good idea. So we need to write in two significant figures. So I will encourage 4.0. Can you see that? 4.0, 5.6, 9.6, 15, but we don't write 15.0 lah. If 15.0 is three significant figure. From here, their answer A, B, C, D, they are make it in two significant figure. So for us, if paper 2, we write working step. So I will encourage you final answer, we make it in two significant figure. Okay? Of course, they accept 2 to 3 lah. Most of the time, their answer scheme will be 2. Okay, good job. Boys and girls, we go to the 11. Okay, 11 here. When you saw a triangle, something like this, actually they like to involve with the sine, cos, tangent. Okay, 大卡数. So I'm not sure if you are foreigner, do you know about this tua kaso? By Malaysia, if the teacher teaching mathematics, we like to say tua kaso. That means that their leg actually is like the auntie having a big leg, something like that. Okay, tua kaso. So at here, we're having a look. A constant force acting on a car of mass m move the car up a slope through a distance at constant velocity. The angle of the slope is alpha. What is the ratio of gravitational potential energy gained by the car divided by work done by the car? Okay, gravitational potential energy is mgh, right? Then this one work done, F equals to work done equals to Fs. So basically, we have to solve this. But the problem is, teacher, where is the h? Remember what I teach you last week? Okay, I taught you the gravitational potential energy, the force and the displacement must be in the direction. So let's say the object, this is the object. This is the weight, mg. This is the weight. Where is your h? Your h must be in parallel with it. But now my problem is I don't have h in this question. So what should I do? So boys and girls, can you choose? Either you're using sine, cos, or tangent to find out the h. Then you do substitution inside the h here. Okay? Using your mathematic method, sine, cos, or tangent, you choose which one is suitable right now. Okay, then you find out your h. Then you do substitution in, then you should be able to get the answer. Okay, can you try? And then you tell me. Tuaka, that means the big leg. So that means auntie. In Malaysia, we call aso. It's auntie, something like that. So it's helping us to remember. So that means sine, opposite divided by the hypotenuse, something like that. It's quite interesting way to memorize. Okay, like boys and girls, try. Actually, work done is energy. Energy is work done. Correct. Machine, okay, correct. How about others? Do you able to get the answer? Okay, here, can you see that? This one. If I draw the triangle out, I have the S hypotenuse. I need to find the h opposite to the angle. So at here, we choose this one sine. because opposite and hypotenuse. So at here, the sine alpha is equals to opposite h over s. So what is our h? H is s sine alpha. So if I do substitution mg, then s sine alpha divided by fs. So can you see that s and s can be cancelled out? So my final answer should be mg sine alpha over f. So for this question, they're just testing you. Do you know what h you want to use? Are you using the s or you using the h? Okay, they want to know about this. Then after that, do you able to find out what is your h by using the triangle, your mathematics? So in our A level, actually the what physics you need a strong mathematic concept okay. Yes, Kai Chen, D is correct. Okay, boys and girls, if no question, we goes to page number 9. Is it okay? Give me some response. There's a button. Give me a response. Thank you. Okay, dear, come. This is 2022 question. Okay, move down. The child move from rest. So that means that starting at here, they are at rest at the top. And then average resistive force, resist the force 76 Newton oppose the motion. So there must be something lost to the surrounding lah, because we oppose the motion. Okay, then after that, kinetic energy at Y. So at here, kinetic energy is 300 joule. Decrease in GPE as it move. Okay, so how much it decrease? It will decrease 3,200. That means that from here until here, we lost GPE 3,200. Meaning that at start at here, because here we assume there is no, at here we assume that is already on ground. Okay, on ground. So at here, this is GPE with 3,200 joule. Okay, it decreased the potential gravitational potential energy by 3,200 joule. So that means the at start is 3,200 joule. Can you calculate the kinetic energy of the child at Y? At Y, okay, at Y here is 300 joule, 300 joule at Y here. Okay, 300. What is the kinetic energy of the child at Y if there is no air resistance and no frictional force? Like boys and girls, what do you think? If I continue guide you, then I told you the answer already. Okay, tell me. The upper part is with resistive force. What is your kinetic energy? Actually, they told us 300. But what if no resistive force? What is the kinetic energy? No, Fawal, no. Vashini, but this is not your final answer. You need to find the ratio. Yes, correct, Vashini, correct. How about others? You type your answer, then I know your idea, okay? I trying to understand your idea. So we try to find out which part the idea is wrong, or maybe you missing some important knowledge. How about others? Let me have a look. Hai Qian, no. What is the kinetic energy when there is no resistive force? Remember, when there is no resistive force, no losing to the surrounding. So what is your kinetic energy at point Y? What is your kinetic energy at point Y? No fraction, Tony. No fraction in final answer. Can you try to do calculation for the decimal place? Farewell. This is the answer. Your answer is for the kinetic energy without resistive force. Yes, but you have to find the ratio out. Prasan still here? Yes, correct, Tony. Remember final in physics, final no fractional force. Farewell, no fractional force. No fraction. No fractional force. No fraction. Make it decimal place. Jore, no fraction. Why everybody give me fraction? No fraction. Make it decimal. Okay, but most of you get the answer lah. Okay, can you see that at here? When there is some friction, final kinetic energy is 300. So for this question, it should be 300 divided by kinetic energy at Y if no resistive force. If no resistive force, no this, no losing, it's perfect. If perfect, starting is 3200. What is your final here? It should be also 3200 joule. Am I right, dear? Am I right? Because energy cannot be created, cannot be destroyed. It can be only transferred from one form to another form. Then we don't have others form already. No friction, no others form. So all the 3200 joule, it will transform perfectly to the final kinetic energy. So at here, it should be 32,000. But cannot simplify, then at the end you give me 3 over 2, 32. 3 over 32 cannot. Give me some 0.094, the decimal. Oh no, no, we can get in decimal. Okay, like boys and girls, use your answer in A to calculate the ratio of speed when the child at Y when there is a resistive and the speed of the child when there is no resistive force. Involved with speed. So you have to think about the formula energy involved with speed. So I can give you the hint is 1 over 2 mv squared. So boys and girls, can you try? What is the speed, okay, with resistance, and what is the speed ratio without resistance? No resistance. Okay, your final answer should be in this, then you find out the decimal. Okay, like boys and girls, try. 1 over 2 mv squared divided by 1 over 2 mv squared equals to what? Because we want the speed, the formula related with the speed and related with the energy is 1 over 2 mv squared. They ask you use your answer in A. So think. Rasan, correct. How about others? Speed relate with energy. So this is the formula that we can use. Okay, speed related with energy. Rashini, correct. How about others? Pawal, Pawal, Tony, Vito, Wesley, Kai Qian, Chai. It's okay. If wrong, also never mind. Fatima, you may try. I take attendance at the same times. Okay, let me check your answer. Jory, correct. Like boys and girls, how we solve this? Since they say that use the answer in A, this is energy divided by energy. So energy, kinetic energy divided by kinetic energy, you will get 0.094. But at the end, I want the speed with the resistance. So actually, I want this part. I want this part. Okay, I want this. So at here, 1 over 2 can cancel, m can cancel. So we will get VR squared divided by V, no R, square is 0.094. So V out divided by V no resistance 1, the speed without resistance 1, actually should be square root 0.094. Your answer at here should be 0.31. So your answer here 0.31. Right, boys and girls, this is the answer. They need you to think how you relate kinetic energy and speed. So you're using the formula. Then this ratio and the bottom part B question ratio, they are the same, equals to 0.094. Okay, right, boys and girls. This one, if no question, continue with C. Calculate the length from X to Y. From X to Y at here. What is the length? Okay, so at here you understand that as starting is this 3,200. Final you only have 300 joule. That means that there is a lot of work in doing to overcome the friction. So what is the length in order to overcome the friction? Work done in overcome friction. How you do calculation for that? Work done in overcome the friction. W equals to Fs. So, do you have your force? Read the question again, is provided at here. Okay, what is the length? Actually, is our S. Distance travel, or we said displacement. Okay, can you do calculation? I already guide you. Starting, ending, there is some losing due to the frictional force. Then after that, the frictional force, you can do calculation with F times S. The S actually is the displacement from X to Y. So for basically question asking you calculate the length from X to Y. Actually is this, we're finding this S. Like boys and girls, try it and then tell me. What is the length? How long the length? How far they travel from X to Y? Vashini, correct. Good job. Actually, this idea same like our doing objective question there. Huh? Kai Qian, no. You may try again. Check whether which part is wrong. No, Fatima, no. Your answer same as Kai Qian. So later on you check what is the mistake part, then you let me know. At least I know, you let me know, then I will know, understand that actually how student thinking about that. Okay, so boys and girls, how about others? Jore, correct. Two significant figure. Vowel, correct. Okay, like boys and girls. So at here, you got starting is GPE, final is kinetic energy, but in between here, we're doing some work to overcome the friction. Okay, GPE at here 3200, kinetic energy is 300 plus the friction Fs. So at here 3200 equals to 300. We use 76 force to oppose the motion. So plus 76S. So actually at here you will get 2900 equals to 76S. Your S should be 38 meter. This is answer for C. Okay, Fatima, you help me to check and then tell me why you get 40 something. Kai Chen, correct. Wesley, correct. Wesley, correct. Can you see that this idea actually is same like just now we're doing the MCQ, okay? But MCQ just now is directly tell you how much they lost. You didn't add the 300. Oh, okay. But do you understand right now, Tony? Correct. So Fatima, do you get the idea? Kai Chen, do you get the idea? Okay, good job. So can we proceed to the page number 10? Give me response. Okay, good job. We make mistake, doesn't matter, no, don't be shy, okay? People don't know how you looks like, okay? It's okay. So you just ask the question, okay? Like boys and girls, we go to the question number 13. Okay, here a car of mass 1700 move in a straight line along a slope that is at angle, okay, certain angle right now. Then after that, they say the car move at constant velocity. I was always trying to find some keyword. Constant velocity for distance. Okay, from point A to point B. So they move with constant velocity. Air resistance and friction provided a total resistive 440. So this one is friction. Force for friction oppose the motion for the car movement from A to B. State the change in kinetic energy. Change in kinetic energy means that kinetic energy final minus kinetic energy initial equals to how many? So what do you guys think? Try to answer me. Let me check. Jore, zero. Jore, correct. You know why it's zero, boys and girls? I already asked you to highlight the keyword. Constant velocity. That means that your U and V all the time is the same. If they are kinetic energy maintained, there is no change. No change in kinetic energy. So at here, our answer is zero is because your constant velocity. If I using 1 over 2 mv square minus 1 over 2 mu square, u and v are the same. So at the end you get 0. U and v are the same. You didn't change the velocity at all. Okay? So for this question, it should be 0. Okay? It should be 0. But I thought provided... Okay, Wesley, yes, air resistance and friction, they provide a resistive force. But right now, the question is asking you, is there any change in kinetic energy? Okay, is there any change in kinetic energy? So you're talking about kinetic energy from here to here. Okay, from this point, what is the kinetic energy? 1 over 2 mu square. What is final velocity? Final kinetic energy? 1 over 2 mv square. So since constant velocity, then they will having same u and v. So at the end, no change in kinetic energy. But of course, at here starting, maybe it still have some extra energy, not only kinetic energy. Okay, then they do some work to overcome this. At the end, they provided the kinetic energy at here. Okay, so maybe we go through first. Okay, later on we see is there any mentioning about it. Movement, they apply extra force. I think they accelerate the car. Okay, here now it's talking about kinetic energy. Constant velocity. So kinetic energy doesn't change. Okay, work done to overcome the total resistive force. How much work it need to do in order to make this movement? So it's here work done. W equals to Fs. Right, boys and girls, you try. How much force you apply to overcome resistive force? How far distant your car is moving? Correct. Wesley, correct. But we want, you may try to make it like times 10 power of how many? Yes, correct, Fawang. Actually, I'm not a mathematics teacher lah. I'm asking you guys. If 11000 is two significant figure, is it what two significant figure? If 11000 is it two significant figure? Yeah, okay, then no problem. Then you want to write 11000, no problem. Or you want to write 1.1 times 10 power of 4, no problem. Okay? I'm not teaching mathematics, so not really sure about that. Okay, here, the force that we apply is 440 times the distance at here is 25. So you will get 11000 joule. Don't forget unit is joule. So this one, two significant figure. 1, 2, two significant figure. Okay? Let me have a look. Any of you got question or not? Five significant figure, Vashini? 11000 is five significant figure? Vashini say is five? Like somebody help me to clarify. To be more safe, this one confirm lah. It's two significant figure. 2, 3, 4, 5. Jore can be 2, 3, 4, 5. Huh? Can be 2, 3, 4, 5? Okay. Well, I just know that we want two significant figure for our final answer. 2 to 3 lah, okay? So this one maybe I ask mathematics teacher. Okay, like dear. Movement of the car in B from A to B cause its GPE to increases by 4.8 times 10 power of 4. Okay, So cause is gravity to increase. So we increase GPE. We got GPE increases. Okay, we increase GPE with 4.8 times 10 power of 4 joule. Okay, so can you help me to count what is the height at here? What is the height? GPE formula. Correct, Washini, correct. Wesley, you using 1,200, but 1,200 from where? The mass is not 1,200. Maybe you do substitution wrongly. Fawal correct. Prasan correct. Yes, Wesley correct right now. Victor, yes, correct, Victor. Make it two significant figure. Of course, 3 also correct. Okay, boys and girls, the GPE is mgh. Okay, so 4.8 times 10 power of 4, the mass of the car. So this one going down, this is mg. This is a force, okay? So of course, this force, you have to find the parallel distance. This is the definition, or this is the rules for us to using the energy. So mg is 1,700 times joule 9.81 times the h. So your h should be 2.9 meter. 2.9 meter. Okay, it increased by this amount, GPE. Okay, can you calculate the angle? You see always angle, then think about just now what I told you, the auntie with the big leg. Then you try to find out. Correct. Fawal correct. Good job. Thinking about the tua castle. So what is the angle? Prasan, after the point, slightly different with me. Hmm? Is it you using 2.88 or you using 2.9? I have to find my calculator. Because I was sent like just now for a while. Oh, you using the previous answer, okay lor. Using the previous answer. Vito correct. Kai Chen two significant figure, then you will correct. Fatima correct. Okay, dear. Our answer at here 6.7. Okay, we here this one triangle. Draw it out the triangle. So we get this one is 25m. This is 2.9. Those who slightly different with me, maybe because of this, because you're using the full answer from the previous. Okay, so at here, this is the angle. So tua ka so. So I got opposite, I got hypotenuse, so I still using sine. Sine theta equals to 2.9 divided by 25. My angle should be 6.7 degree. Okay. Let me check. Kai Chen correct. Max error. Never mind. Max error. Do you able to get? Oh, okay, I get it. Okay, Jorel leh? Jorel 6.6. Okay, like boys and girls, any question for this question? If no question, can you times up and let me know? We go to your next page. Okay. So we already go for few past year question. You will found that they will using the triangle and your mathematics. Trigonometry. If I'm not mistaken, we call it trigonometry. Tua ka so, okay, sine, cos, tangent to find. So any of it can be used as long as the information that provided can be used. Okay, not necessarily must be always sine. It can be cos, it can be tangent also. Okay, like boys and girls, we look at this. Oh, this is a very good question. A child of weight 330 is at point X at the top. Then there is an edge at there. So the child move from rest to the lowest point. Then there is a vertical distance 4 meter. So this one hatch is 4 meter below X. The child continue move toward to the point Y, which is at the end of the slide, and a vertical distance 1.1. Okay, this one is another new hash. Okay. Kinetic energy at Y. So we write down kinetic energy is 540 joule. So here it's still moving. That means it doesn't stop at here. It will continue. Phew. Okay, it will continue. So next, calculate the difference in GPE. Difference in GPE. Right, boys and girls? Here I got GPE because I got certain position. Here, standing at Y until point Y, not standing because got speed. Okay, until point Y, I still have certain position. What is the difference between my GPE? Okay, GPE is because of the position. Since Y we got 1.1, so it must also have GPE. But what is the difference between them? Okay, Wesley, correct, but I want you round to two significant figure and unit. Good job, Wesley. Okay, Kai Chen correct. Unit, remember? Washini correct. Fawal correct. Fawal. Okay, so boys and girls, at here I got MGH. Starting I got MGH. This one I got MGH. So what is the difference? Actually, you can do like this. Difference between the GPE is equals to MG change of their height. Or you want to using MGH1 minus MGH2 also correct. Two way, doesn't matter. So it's here 330. Why that 330? Look at here, weight. My weight actually is mg already. So 330 times the h. H at here is 4.0 minus 1.1. So my answer should be 960 joule. Okay, this one just now I go through your answer. Most of you, no problem. Tony, no problem. Okay, like boys and girls, we go here. Average frictional force. So there is a frictional force, okay? In between here, X to Y, frictional force. By considering the change of energy, determine the distance moved by the child from X to Y. Okay, they want to know this distance. That means that I want to know how much work done for the friction, right? Okay, so at here, I start at here, at rest, so it's only mgh. Okay, then at the point Y, we are not only kinetic energy, but we also got GPE. Okay, we also got GPE. Then, if this amount, after you do calculation, this amount and this amount is not the same, because they're still spending some of the energy to overcome the frictional force. So you have to find out what is this and then calculate what is the distance. Is it they want us the distance? Yes, S. Fs. So can you try? Actually, this concept same like just now we did few questions for the MCQ. Starting what is the energy, final what is the energy, plus the losing energy. But Fawal, the behind point what? The one slightly different with me. Maybe it's because you do substitution. Is it you using 957 or you using 960? Eh, 957. If you're using 960, oh, you don't have the question. Wesley, you don't have the worksheet. Okay. Sorry. Actually, I should give you the, yeah, because I don't know. Today you are new. Okay, the force is 52. So I scroll up so that you can answer. Wesley, correct? Tony, two significant figure, Tony. Fawal, correct. Fawal, correct. Vashini, correct. Tony, yes. Okay, Prasan, yes. But here I think it's because you're using 957. That's why our answer will be slightly different now, okay? So boys and girls, at start at point X, energy at point X equals to energy at point Y plus the work done for the friction. Okay? So energy at point X actually is just now the mgh, right? The mgh. So just now, if I do calculation for that, okay, this one GH at point X equals to mgh at point Y plus kinetic energy 1 over 2 mv squared lah, kinetic energy plus the friction Fs. So just now we already say mghx minus mghy. Okay, actually this one is 960. Kinetic energy is 540 plus frictional force 52s. So at the end, if you do calculation, your S, for me, I get my answer is 8.1 meter. So those who get 8.0, I think it's this part lah. This part affected. Okay? But should be fine if you show 957. Okay? Like boys and girls, is it okay for this question? Okay, thank you. So boys and girls, we go to the next page. Next page, okay. Here, oh, this one, the child leave the slide at point. Because just now we said that this one, they still got kinetic energy 540 joule. So it won't stop at here, it will continue, view, go out, okay. So this one is what? Projectile motion. Chapter 2, projectile motion, okay. So at here, the path through the A like this. Okay, point Z is the highest point. Okay, highest point on the path of the child through the A. Assume air resistance is negligible. We ignore air resistance. If we don't ignore air resistance, that means that we still have something lost at this step. But right now, no, there is no losing, no air resistance, we assume. Okay, what is the speed of the child at Y? Okay, at Y here, what is the speed? What is the speed? Speed relate with the energy. What energy can be relate? So you do calculation and then you tell me your answer. Wesley, no. Energy. What is the kinetic energy at point Y? Kinetic energy, because we're talking about speed. So we refer to the kinetic energy. The speed is affecting by the kinetic energy. So what is the kinetic energy at point Y? Oh, because you don't have the worksheet, that's why it's difficult for you to refer. Okay, here, I told you, kinetic energy at point Y is 540 joule. Okay, 540 joule. So if Wesley, after that, if you really join our class, I'm not sure whether today you are what test trial class or what. If you join our class, then you can contact me. I will give you all the worksheet. Okay, like boys and girls. So what is a point Y speed? Speed at point Y. Correct. Wesley, correct. Kai Qian, correct. Good job. Farewell, no. Farewell, no. Your answer same like just now, Wesley. I'm not sure which part. Fatima, correct. Okay, here. Farewell, you check why is different with us. Okay, kinetic energy is 1 over 2 mv square. Kinetic energy, last page we mentioning at point Y is 540. Then 1 over 2, the mass. What is the mass? Okay, the mass at here is the mass of what? Let me have the child. 30. So we have to calculate the m. Where? Should not using 330, right? I should calculate W equals to mg, is it? So this one is Wait. Let me have a look. Your answer is correct, Wesley. 5.7 is correct. Mass is 3. Thank you for calculation for me. Thank you. So this one 330 equals to mg 9.81. So here m is 3.6, Vashini. Thank you. So V at here 5.7 ms negative 1, is it? I don't have calculator. Like Vashini, help me to clarify. Yes, thank you. 5.7 correct, Fawal? Just now 1.6. But why just now is 1.6? 5.7 is correct. Good job, everybody. Okay. So here the mass just now given to us is 330. We cannot straightly use. My typing in my worksheet there, I didn't convert. Okay, I made a mistake. Okay, can put meter per second. Okay, Wesley, meter per second, then you must be graduate from IGCSE. IGCSE, we're using meter per second. Okay, in SPM, we're using ms negative 1. When it comes to A level, we're using this method. Okay, ms negative 1. We're using this way to represent our unit. So you have to change your way. No choice. IG, no problem. Yes. Okay. Like boys and girls, we go to your next. This is a very good question. It's related with your projectile motion. Okay, like boys and girls, we look at this. Highest points at Z at here. This is projectile motion, which means that it will having two components, horizontal and vertical. Okay, horizontal and vertical. At highest position, your vertical velocity, it will be 0. Do you agree? We say if one dimension, if one dimension, the ball we throw upward, maximum height, we will say that final velocity is 0. Is it correct? This is one dimension. This is Vy. So at this position, your Vy is actually 0. But it doesn't mean that there is no velocity. Don't forget, in our projectile motion, we still having this. Dear, Vx. So what is your velocity, horizontal component velocity? Vy already don't have. Then we need to have a look about the Vx. So at here, can you calculate for me what is your Vx? This velocity u is 5.7 ms negative 1. This is what we count at point y. What is your Vx? In projectile motion, okay, horizontal component, what will be always remain constant? What will always remains constant, my dear? So, velocity, yes, horizontal velocity. More accurate is horizontal velocity will remain constant. Acceleration pulling downward due to the gravity, it doesn't affecting your horizontal. This is projectile motion lesson, page number 1. If you already forget, go back and refer. Page number 1. Horizontal component velocity will be constant. So which means that this velocity will equals to this. So can you help me to calculate what is your horizontal velocity? Correct, Vashini. Good job. Fawal, no? Fawal? Fawal, no? Kai Chen, correct. Vito, no? Vito, no? Like this, This is 5.7 ms negative 1. I want to know about this. What is my ux? Ux is Vx. Horizontal component is constant. There is no other external force acting on it in the horizontal component, because at here we assume air resistance is negligible. Ignore. Fawal, correct. Wesley, no. Wesley, no. 5.7 is Wesley. 5.7 is here. This one is 5.7. Now we need to find this horizontal. Let me check Fatima. Fatima, correct. Good job. Vito, correct. Okay, Vito, correct. Like dear, this 5.7 is what you count just now. This is the speed. But now we are going to find the horizontal velocity. It's because our vertical is 0, so we only depends on this horizontal Vx. So at here, it should be, let me check Wesley one. No? Okay, like here, this one, it should be ux equals to 5.7 cos 41 degree. Your answer should be 4.3 ms negative 1. Right here. Is it correct? Forget to times 5.7. Yeah, okay. Okay, boys and girls, the rest, page 13 and 14, actually for you to self-practice, for you to do self-practice. If no question, then we can go to lesson number 21. All the self-practice question I provided the answer at the bottom, so you can checking. If you really facing the problem, don't know a working step or not sure, you can contact me in my WhatsApp, okay? So I will show you the working step. Okay, I can print screen to show you the working step. Okay, like boys and girls, we go to lesson number 21. Any question? No question, give me the response. Reaction. Okay, good job. Okay, this one, power and efficiency. This one actually year 10 we learn power is work done divided by time, or we say energy divided by time. So power is actually work done divided by time. Okay, this work done can be Fs, energy can be 1 over 2 mv square or mgh, whatever. They will be the same, okay? They will be the same. Unit is watt, W, okay? Capital letter W, watt. Now we add something new in our A level. Okay, power needed to remain or maintain constant speed. Okay, how big the power we needed? So at here, I put a star is because you have to know how to derive. At the end, you get this formula, P equals to FV. This formula, you have to know how we get it. That's why I put a star here. Okay, P equals to W over T. W is work done, Fs. Fs divided by T. S divided by T, as distance divided by time, actually is velocity. So we get another formula, power equals to force times velocity. So A level, we learn about this. But if you are Form 5 student, SPM students, graduate from there, actually you know this formula. Okay, you will know this formula. Okay, like boys and girls, can you try? Okay, power. A man 75 kg. Run up a staircase 30 steps. Each step is 20 cm. Remember, at the end, we are in watt or in joule. For energy is joule. For power is in watt. This is SI unit. SI unit. So you don't forget to convert the prefix. Okay? The man take a time of 7 seconds to run from the bottom to the top. What is the rate of increase of gravitational potential energy? Okay, dear, this question asking you energy or asking you power? Like any of you know? Type in the chat box, let me know. This question asking you energy or power? Power, Wesley, correct. If you didn't refer to ABCD, the 1 watt, how I know? Rate. Rate. Rate is the keyword. What is the meaning of rate? I told you already, right? Per unit time. Per unit time. Sometimes they was like that. They don't want to tell you that what is the average power of the man. They want to play the word with you, okay? Rate of increase of gravitational potential energy. Like boys and girls, do your calculation and then tell me your answer. Okay, Fatima, correct. Fatima, good job. Prasan, correct. How about others? Vashini, correct. Like one or two more students answer, then I know that most of you already complete. Wesley, correct. Fawal, Fawal, no, Fawal. Like we check answer, Fawal. Okay, here power is energy divided by time. Here energy is mgh divided by time. So at here your mass is 75 times 9.81. The h at here, the total height, actually each of them is 20. So 20 times 10 power of negative 2, but this is only for one. You got 30, so you have to times 30 steps. Divided by time is 7.0. So at the end, your answer should be 630 watt. Like boys and girls, answer should be C. Like check. Kai Qian, C, correct. Okay, follow check. So if no question, you guys can go to the page number 2. Okay, you try it. Now here I stop for a short while for those maybe you want to check the answer or you want to write something. Okay, the rest of you can proceed to the page number 2. You don't have it? Oh, sorry. Sorry, Wesley. Okay, here. Okay. Vashini, correct. Fawal, correct. Good job, Fawal. Fatima, correct. Fawal, just now the one is because of you forget to times. You forget the G, is it? Okay, so next time cannot be, this is considered careless. Okay, so next. Any others? Power 20 kilowatt. This is P. Okay. Lift and passenger combined. This is the mass M. Then the motor rise. Rise is the keyword. Okay, so I know it's mgh. Okay, so power is equals to mgh divided by time. Mass is 1500. G is 9.81. The h is 20 divided by the time is how long the time? Oh, okay, we want to count time. This is 20,000 times 10 power of 3. Prefix, prefix, chapter 1. Chapter 1, we already talked about prefix. Prefix is very important. Okay? So here, Kai Qian correct. Wesley correct. So answer will be B. T equals to 15 seconds. So everybody get it, So we proceed to your page. Proceed to your question number 3. Okay, this one. Mass, underline mass. Okay, it jump vertically. Okay, it jump vertically. It take the time t. So this one, right? T. Leaving the ground with a velocity. That means that leaving is meaning starting lah. 3 meter per second. So this is your U. Okay, what is the average power? Okay, power is actually energy divided by time. I got time, yes. Then the energy, what kinds of energy do we have? Okay, so at here, because it's jump up, so we will gain GPE, am I right? We will gain GPE, it jump up. Okay, so here I will get GPE. So it will be mgh divided by time. M is 0.12, no problem. G is 9.81, no problem. But the problem is, teacher, I don't know the h. Time I know. Time, did I know? Yes, 0.02. The problem is I don't know the h. Any of you got idea? How can we calculate the h? This is related with chapter 2. Yes, chapter 2. No? How you get this? Okay, any idea? Any of you got idea how we calculate the distance here, the h? This is related with what? Chapter 2. Chapter 2. Kinetic. The linear motion equation. Boys and girls, do you still remember? Chapter 2. Okay. Chapter 2, we got four formula. V equals to U plus AT. S equals to 1 over 2 U plus V times T. S equals to UT plus 1 over 2 AT square. V square equals to U square plus 2 AS. Like boys and girls, this is chapter 2 linear motion equation. Can you using this to find it out? What is your h? At here, h actually is the distance traveled, so actually it's our S. H is your S. What is your S? So what formula you can use? Starting is 3 meter per second. So jump vertically, so it will getting to the highest maximum height right here, maximum height. Okay, so maximum height at here, velocity is 0. Your acceleration, it will be negative 9.81 meter per second per second. These two information is you know by yourself. They won't tell you. Like boys and girls do calculation. Oh yeah, 0.12 have to convert. Yes, I thought 0.12 is so small, it's already in kg. Like, thank you, Wesley, for remind me. I didn't realize this is gram, it's not kg. So this one should be times 10 power of negative 3. Thank you. Okay. So we always be careful with the kg. Be careful with the unit. Okay, so at here we got U, V, A, S. We want to find S. U, V, A, S. U, V, no S. So this one cannot. U, V, no A, cannot. U, V, no V, cannot. So what formula we use? We use this to find your S. Okay, to find your S. So at here, my V square, V is final 0 square equals to U 3 square plus 2A negative 9.81 S. Sorry. So what is your S, like dear? Did any of you get the answer for this question? So when we solve a S question, we are not topic by topic. We are a lot of topic we combine together. So you don't keep on thinking about the work and energy only, but you also need to combine and get back the knowledge regarding others chapter. Okay, like boys and girls, any of you get the answer for this question? I didn't round off for the distance first, because I can straightly put it in. Let me check for a while. Yes, Farwell, correct. The distance is 0.46. So when you put it in inside the power formula, can you tell me what is the answer? Correct, Farwell, correct. Washini, correct. Wesley, correct. Others, Tony, Jory, Prasan, is it okay? Our answer will be C. If you press calculator, you will get 0.027 watt. Okay, so for this question, they want you to apply the knowledge about the linear motion equation. You want to using kinetic energy. Kinetic energy. Cannot use kinetic energy. You may try. You may try kinetic energy. You try, see whether you actually in physics there is a lot of method to solve. A lot of method to solve. So I cannot say that this is the only solution. Okay, maybe you can get other solutions. So Jore correct, far wow, kinetic also I think it's the same. I use kinetic energy first. Okay, no problem. In physics, we got a lot of method to solve, not only one. Okay, so I cannot say that others method cannot. So we have to try first and see how. Okay, so the idea is conversion of energy lah. Okay, next, let me have a look. Okay, like boys and girls, if no question, it goes to page number 3. Is it okay? Give me reaction. Fawal already helped you to prove. Fawal say can, Fawal already proved. Okay, like boys and girls, thank you. Like boys and girls, come here. Like do calculation. Now they give you force. Instead of they give you energy, they give you force. Then the car, this is the distance s. Then this is the time. Power. Okay. So try. What is the power? Just now, the one new formula actually is what times what, then divided by what? Oh, very fast, questioning. Yes, correct. Power correct. Wesley correct. Wesley not correct. Wesley not correct. Haichen correct. Fatima not correct. I think Wesley and Fatima, because you missing something prefix. Yes, Wesley, right now you are right. Okay, so power is actually work done divided by time. It's Fs divided by time. Just now, we derive the formula. So we comes to this step. So 600 times 1000 times 10 power of 3 kilo. I think Fatima maybe is this part. I'm not sure. Okay, maybe this part. Then divided by the time is 150. Your answer should be 4000 watts. So answer is B, 4 kilowatt. Okay, let me have a look. Next, Fatima correct right now. Tony correct. Like boys and girls, we comes here. Okay, without my guidance, do you able to solve? Power equals to, now involved with velocity, so we can using our new formula, FV. Okay, kinetic energy, power. Oh, you see, if you didn't read carefully, you would think about kinetic energy. This is what first come in my brain. But actually, it's rate of the kinetic energy. That means power lah. They're asking you power. Okay, like boys and girls, here, net force times your velocity. So many force at here. Which force we are going to use? Tony correct. Wesley correct. Yes. Power equals to 500 minus 500k minus 200k times your velocity is 40. So at here your answer is 120000000 watt. So many zero. Okay, 60 represent your mega. Prefix, boys and girls, tera, giga, mega, kilo, deci, centi, milli, micro, nano, pico. You can using your calculator to help you, 10 power of 12, 10 power of 9, 10 power of 6, 10 power of 3, and this one 10 power of negative 3, 10 power of negative 6, 10 power of negative 9, and 10 power of negative 12. So this one is 10 power of negative 1, negative 2. So right now, mega is times 10 power of 6. This is our answer, mega. You can using your calculator to help you to find the prefix. Okay, so what I want to say. You press 1. You press OPTN on your left hand side. The calculator button, second button, left hand side OPTN, option. Then you choose number 3 engineer symbol. From the engineer symbol, you key number 3 go in, then you will saw the prefix. Okay. Deci not necessary, but centi yes. But I cannot say Deci have to memorize. When we doing lesson chapter 1, we do the prefix question. One of the question or answer is involved with Deci. So Wesley, we have to know. Deci also, yes. We have to know. Now I just realized that chapter 1, when we doing the exercise, we saw Deci before that. Okay, like boys and girls, if no question, we goes to number 6. Okay, a variable force is applied to ensure that constant power is constant. It's supplied to the train. Okay, so at here, involved with force and velocity. So power is force times velocity. This power is constant. So what is the relationship between force and velocity? Correct, Wesley. Correct. So Answer is, how about others? Fatima, no? Washini, yes. Tony, yes. Kaichen, yes. Fabo, yes. Okay, dear. You see, constant. That means that if your velocity increase, your force must be decreased. These two side by side, their relationship actually is called inversely proportional. One big, another one must be small, so that you can get back a constant P. Okay, you can get back a constant P. So inversely proportional will be A. Okay, they're testing on you about the knowledge of the graph. So Jore A correct. Like boys and girls, answer A correct. No question, we goes to your page number 4. Give me reaction. Give me reaction, is it okay? Okay, like dear, we goes to your next page. Okay, can you try? Let me have a look, What is the answer for 5? Okay, Jiahan here, answer for 5 is C. Okay, like boys and girls, question number 7. Here I stop for a short while. Jiahan, is it okay? This question? Okay, like dear, we goes to here. Okay, the force resisting the motion of a car is proportional. Like this. This is a symbol of proportional. So they say force is proportional to the square of the car speed. So square v square. Okay, this is the meaning for first sentence. The magnitude of the force is at the speed of 20 meter per second is 800 Newton. What is the useful power is required for the car engine to maintain a steady speed of 40 meter per second? Okay, so at here, power, which is involved with V. So we understand power equals to FV. So this one, they say that when they are 40, what is the power? So that means that I have to calculate out what is the F when it moving with 40 meter per second. Just now at here, they tell us this speed, the force is 800 Newton. But how about 40 meter per second? What is the force? Okay, how we solve this question? Okay, we should Prasano. Prasano. Let me have a look. Yes, Fawa correct. Fawa, good job. Okay, dear, like come here. I guide you. Force directly proportional v square. In mathematic way, equation, we cannot using directly proportional. We should using an equal. We change this form to equal. But I cannot just put equal. I need to put a constant number, okay, constant value. So F equals to KV square. Okay, so at here they tell you that when 800 Newton, the speed is 20 square. So you can calculate this constant value first. Constant. This is a value that it won't be changed. Okay, what is this constant value? Then again, F equals to KV square. Now your speed become 40 square. 40 square. Then your K actually is this answer. What is this answer? You substitute inside here, K. Then you get your force when they are 40 meter per second. Then after that, you substitute this answer, goes to here. Then you will know the power. Okay? So today we learn something new technique. Yes, Prasan correct. Kaichen correct. Oh, everybody is so good. Tony correct. Vashini correct. Good job. Wesley correct. Wow. Yes. Good job. Okay, so dear all, you have to understand directly proportional change to equal. We have to put a constant value, and this constant value, it will be the same. It's something like, do you remember the spring constant? The one, what? Hooke's law, F equals to Kx. Your extension, your force increase, your extension will increase. This K actually is a constant value. It depends on your spring, stiffness of your spring. So we will say that the force, the load, the force is directly proportional to your extension. So in order to form the equation, we will get F equals to Kx. Okay? Right, boys and girls, so your answer for this question will be C. Okay, here I get 2. So here 2, So here I get 3200 Newton. So here 3200. Then at here I get 128,000 watt. So which means that 128 kilowatt. Okay, any question? No question. Give me response. Then we goes to next page. We goes to next question. Okay, good job. Okay, dear. Then we goes down. We go down to the question number 8. Question number 8. I will draw diagram so that I will be more clear picture about this question. Because here the train of mass 3.3 times 10 power of 6 is moving with constant speed. I always trying to find some keyword in the question. Okay, with inclined plane at an angle 0.4. So at here, maybe I can draw something like this. So here is 0.64. Okay. Okay. The engine of the train is producing an useful output power. So this is the power provider P. Mega, C mega, again prefix. If you don't know what is the prefix, a lot of question in our Cambridge AS, you cannot solve. So please make sure you are very familiar with prefix. There is no frictional force, okay? So if let's say this is the object here, no frictional force oppose the motion. What is the speed? Okay, power is equals to force times V. We want to find the V. Power already given 14, 4, 1, 4, then 0, 0, 0, 0, 0, 0, 4, 0. Mega is 40 times 10 power of 6, 40. Okay, now is they want you to calculate your speed. What is your force? What is your force? Which direction of your force you should have? Okay, so at here, boys and girls, this is our weight. This is the force acting on the object by the gravity pointing downward. Is it this can be our force? No, the force is the same direction as your motion. Okay, so from here we can split it out. We can split it out. Resolve it into x and y. Okay, resolve it into the parallel and the perpendicular. Prasan, no, not correct. You may try again. Okay, here this is the this one should be here should be 0.64 degree. If you are graduate from SPM, you know this very well. If you are not, okay, so I explain again at here. This one is, for example, this is 30 degree. Here is 90 degree. So of course here is 60 degree. Okay. Then this one is the force like this. Then 90 degrees. So of course here will be 30 degree. So this angle and this angle are the same. Same like right now, 0.4 and here this angle are the same. The idea is here. Okay, now it's going up, right? Moving up with a constant speed. Constant speed means what? Balance force, dear. Balance force. So write down balance force. If balance force are upward force equals to downward force. Left hand side equals to right hand side the force. All will be balanced. So which means that what force I want to find? I want to find this force. It's going up the force. This force is equals to my green color, which is mg sine 0.64 degree. You get my idea? This one involved with resolution of forces. W is the mg. It will split into parallel to the plane and perpendicular to the plane. Perpendicular to the plane, we no need to know unless they're asking us to find normal reaction. But no, I want to know how fast the speed of the train. So I need the force which is parallel to the plane. So I need to find this F. Because the keyword constant speed. So it must be equals to my mg sine 0.64 degree. So you do substitution, do calculation, put it in. Can you tell me what is your answer for your V? Kai Chen, correct. Good job, Kai Chen. Fawal, correct. Get the idea, Fawal? Vashini, correct. For this question, you guys able to get my explanation, Okay. We want to find the force which is same direction as your motion. Okay, so we need to resolve our weight. Wesley, correct. So at here, our force is mg sine 0.64. Okay, Wesley, you because I think you are from graduate from IGCSE, right? Do you able to get this idea, this triangle? Why here is 0.64? Because this is the first time you are in our class. I will read this part. I didn't explain clearly. Do you get able to get this idea? For Wesley? On mathematic terms, I don't know lah, okay? But here, do you look at this, this is triangle, right? This is the triangle. In order to easier, I using 30° as an example. So this is 90°. Here is 90°. Of course, here will become 60°. Okay? Then after that, this one, I resolve into the x and y. I can think like parallel and perpendicular lah, okay? So this is parallel to the plane. This is perpendicular. They are 90°. So here 60, here will be 30. So we will know that this 30 and this 30 are the same angle. If you're using your mathematic term, I really don't know lah. Okay? So at here, answer here, mass. What is a mass? What is the mass? Okay, here, 3.3 times 10 power of 6, G 9.81, sine 0.64 times your V. So 14000, where is 000? Oh, so many zero. V is equals to 39 ms negative 1. Answer is C. Like boys and girls, any question? Okay. Then we goes to your page number 5. Like dear, page number 5. A car of mass 1,400 for 1,400 kg is traveling on a straight horizontal road at a constant speed. So here that means that they give you the speed 25. Okay, then after that the output power is 30 kilowatt output power. Horizontal. Right now this part is talking about horizontal. That means that talk about first section. Okay, first section. Then the car then travel. So this is second section. Okay, second section. So which means that we divided into two parts here. Okay. What is the output power of the car engine when it traveling up the slope? Okay, normal we already got this power. Then we want to go slanted, okay, path. We need extra work. We need extra power. Okay, so what is your output power here? Actually, you should have your normal power on the horizontal. Right now, you're going up. We need extra. Okay, we need extra work. Extra work. This extra work is due to the we want to against the gravity lah. Okay, because the slanted. Okay, so at here, yeah, Wesley, correct. You give me this answer, right? Yes, correct. Like others, this one is horizontal power, which is how many? 30,000. Extra work. Extra work. What is the power that you need? Then you tell me what is your final answer. My boys and girls try. Shan, correct, Shan. Correct. Normal run, we need 30,000. Now we need extra work, okay? Go slanted path, we need extra work. So what is the power for this extra? F times S. This question relate with this slanted question. related with this question. What is your force? You cannot using the weight. You cannot using the weight. You have to from here, then you have to resolve it. What is your force? Okay, you have to resolve. What is your force at here? Okay, what is your force? So this one is mg. Here is 2 degree. So this one, force should be mg sine 2 degree. Okay, right, boys and girls, let me check your answer. Vashini correct. Who else? Fawal. Fawal no. Fawal no. Kai Qian no. You and Fawal answer are the same. Your answer and Fawal answer are the same. Not Fs, dear. I write wrongly. Power is Fv. Power is Fv. So 30,000 plus the force. What is the force? In the motion. Force in the motion. So you should resolve it. Fawal correct? Correct. So at here, the force should be mg sine 2 degree. Then the speed at here is 25. So at here, 30, 1, 2, 3 plus 1400 times 9.81. Sine 2 degree. So times 25 if V. F times V. Just now I write Fs. So here you should get 41982 watt. This is my answer. But we round to two significant figure, it will become 42000 watt. So that means that C. Answer is C. Okay? So this one, actually, the part is here. This part, actually, how we solve is same like just now, the previous question number 8. Okay? Kai Qian correct. Any question for this question? No question, then we can proceed. Let me know. Okay. How about others? Is it okay? Now I just realized that if I holding my hand like this they will the Zoom will surely help me to times out. So good meh? Eh? Is it? Or you praising? Yeah, I think. Don't know. Like next. Like boys and girls, we go to the next question. A loaded aeroplane have a mass 1.2 times 10 power 5. Okay, angle. Oh my god. You see, we always with the angle. So we draw it down. So this angle is 23 degree. Okay. So horizontal with a speed. Okay, with a speed 50 ms negative 1. Okay, what is the rate? Rate. Potential energy. Rate. Asking you about power. Rate is power. Teacher, why power is not unit in watt? No problems, dear. Energy divided by time. So it's joule per second. As joule per second or watt are the same thing. Okay, not necessarily must be in watt. They are in joule per second also equals to watt. Okay, here, boys and girls, what is the potential energy? Actually, it's asking you about power lah, okay? So, energy for mgh, okay? Energy for GPE divided by the time. Actually, it's mgh divided by time, okay? So, any of you? You try? Let me see. Fawal already give me answer. Yes, Fawal correct. Yes, Wesley correct. Can you, Fawal, can you roughly type it out? How you solve this? Right, others? Think about it. Okay. Shanxi, correct. Oh, I mentioned the answer. Yes, answer is C. Okay, according to Fowler, what Fowler did is power, right? Power is FV. Am I right? So at here, force, what Fowler did is, this one is mg. So at here, we split into two. Okay, so the force that we need actually is what? Is the mg sine 23. Then the speed v is 50. This is how the Fowler did. Any of you using this method? Sine 23 degree times 50. Fowler, is it correct? You get C? 2.3 times 10 power 7 joule per second. Yes, okay. Okay. So I think this method is better than my initial idea lah. So I don't talk about my idea. Here, this one more easier. Okay. How about others? Is it okay for this question? Try to draw diagram in our as we trying to draw something labyrinth. Make our brain got a clear picture. That one will be much more easier for us to solve problem. In our A level, we no longer just using formula. Using formula is just like proof what our idea is. Okay, so it's more on thinking. Like, how about others? Vashini, Jory, Tony. This question is okay. Kai Qian, yes. Okay, if okay, then we goes to page number 6. Oh, is it okay? We goes to page number 6. Okay, then next. Like efficiency, boys and girls, efficiency. Efficiency, we know that is useful divided by total. It can be in ratio or it can be in percentage. If percentage, then here we times 100%. Oh. Okay, if you are using energy divided by energy and power divided by power, actually you will get the same answer. No problem. You will get the same answer. Okay, here efficiency, no unit. Because if here is joule divided by joule, cancel, cancel, no unit. Okay, no unit. Watt divided by watt, no unit. Okay? Okay, here efficiency 80%. So which means that 80% energy or power is useful. It's good one, useful. Then 20% is wasted. So when we want to buy something, we can try to count efficiency. If the efficiency is too low, that means there is a lot of wasted. So we don't want. Okay, we don't want. So at here, their efficiency can be expressed in 80% or 0.8. Okay. So boys and girls, come here. Can you do for the first question? Easy. Right, boys and girls. Wasted is 60 megawatt. Useful, useful. Okay, can you calculate efficiency? Correct, Wesley. Vashini, correct. How about others? Tony, Shan, Vito. Vito, today I seems like I didn't saw your message. Not much sewing. Let me have a look. Fatima, correct. How about Vito? Vito, are you here? Okay, dear. Answer is donkey. Answer is donkey. So at here, actually useful. Efficiency, you know that actually there is a symbol for efficiency like this. It's not N, but it's slightly got tail. Something like got tail lah. Slightly longer. Okay, this is efficiency. So useful is 160 mega plus 100 mega divided by total. How I know total leh? Because energy cannot be created, cannot be destroyed. All this added up together is total. Okay, so it's 160 M plus 100 M plus 60 M. Okay, times 100%. Why I need to times 100%? Because my final answer in percentage. So I times 100. So at here, our answer should be 81%. Any question? Wait, my laptop is the Zoom is something wrong. Okay, boys and girls, I cannot see your message right now. Wait, okay, okay, done. Okay, like boys and girls, any question? Give me response. Okay, goes to question number 2. Like here. 74% efficiency of 74%, it weighs 230 watt. What is your useful output? Wow, correct. Prasan, no. Wait, okay. Prasan, try again. Vashini, correct. Shan, no. Shan, no. Shan, try. Wesley, correct. Kai Chen, correct. Hmm. Vashini, can you tell me your idea? Whilst we're waiting for those who make mistake one, you can try. Vashini, do you able to give me some idea? Your idea? I suddenly got another method idea in my brain. I want to prove that whether it's same as you or not. Prasan, correct, Prasan. Okay. What I'm doing right now is my initial idea. Actually, I got another idea lah. Much more easier. Shan, correct right now. N is equals to useful output divided by useful output plus wasted. Okay, that is total lah, times 100%. Okay, so basically the idea is same like just now what we did at here. Okay, total actually is we add it up all. Useful and wasted one we add up together, that is total. Okay, so at here 74% useful divided by useful plus wasted 230 watt times 100%. Then you solve by using your mathematics. Useful is, it should be 650 watt. This is my initial idea lah. I suddenly got another idea. Wasted this, how many percent wasted? 26%. Am I right? Then from here we count 74%. How many watt? Mathematic ratio. But I don't have calculator. That's why I ask you guys, what is your idea? Is it same like my second idea? Prasan, thank you. You proved my idea, second idea. Yeah, actually, first idea, second idea, I told you already, physics got a lot of method to solve it. Okay, so here my idea is 230 watt is 26% wasted watt. So you can count ratio mathematics 74%. So what is the wasted part? So you using this method also can score the point. Okay, answer is C. First method is also okay, but it's longer lah. Method is longer. So if no question, we goes to question number 3. Is it okay, boys and girls? Is it okay? Okay, like boys and girls, come here. Water flow from a lake into a turbine. There is vertical height. So at here, the mass flow. Okay, you see this one is mass divided by minute. So it's mass divided by time. From the unit, we know this. kg minute -1. That means mass divided by time. Turbine has an efficiency 75. Okay, what is the output power? Okay, so here N is equals efficiency is equals to output divided by input times 100%. So this one is 75%. Output, we are going to find the output, but the problem is what is your input? What is your input? So you have to find input first, power input. You have to find the power input. So what is your input? Power here. What is the energy? What is the energy? So it got a high, that is mgh, divided by time. Do you have mass? Do you have mass? I stop at here. I already got you until here. So guys, can you try? mgh. Teacher, I don't have the m. What should I do? But you got m over t, dear. You got m over t. No? Wesley, no? Fawal, no? Fawal, no? Prasan, correct. How about others? You don't have mass, but you have m over t. You have this part. So basically, how about others? Jorei, correct. Okay, so boys and girls, 2400. But this one is in minute. Minute is not a SI unit for time. Please make sure you convert it. Wesley now correct. Kai-Chen correct. So you have divided by 1 minute, actually times 60 seconds. G is 9.81. The height is 90. So at here, your answer for my answer is 35316 watt. So I put at here 35316. My output at here, it should be 2.6 times 10 power of 3 watt. My answer should be A. Sometimes they give you in others form, mass divided by time. So you have to try to using the formula and observe where got m over t. Then that value is really substitute in. You no need to get the time anymore. But have to be careful, this is in minute. Okay, is it okay? Like boys and girls, is it okay? If okay, give me times up. Times. Give me response. Okay. Okay, boys and girls. Question number 4, I want you to try by yourself. The idea is almost the same. The answer for this one, you write it down at the bottom part. This answer should be B. You try. If cannot, then you can message me or maybe next week I show you the working step for B. Is it okay? This one, you write down final answer. Then you try it after that. Is it okay? Okay, then we goes to the question number 9. I want to talk about question number, not question number 9, page number 9. Like dear, page number 9. An escalator is 60 meter long. Okay, if I draw a triangle, that means here is 60 meter. Okay, 60 meter long. Vertical height is 30 meter. You see triangle already or not? They like to give you triangle and then either find the height, find the distance travel, or find the angle. So from here, obviously they want you to find angle. The triangle. Oh, here, dear. Firstly, here, this one. If with angle, so this one with angle, so it's triangle. Okay. So at here, see 90 degree. This triangle. Okay. Can or not, Wesley? Okay, to drive the escalator against the force of friction when there is no passenger, no passenger, now you only see the question. Okay. maybe some delay. Okay, like boys and girls, without any passenger, just normal walking, in order to overcome the friction, it already need 2 kilowatt. It already need basically it need 2 kilowatt. The escalator is used by the passenger of average 60 kg. So now our mass for one person 60. And the power to overcome the friction still the same. So this 20 kilowatt for the friction, no matter how many of you standing, is the same. The friction is the same. But now, since you need to carry the passenger, you need extra what? Extra power, okay, to carry all these 20. Now it's 20. Total one person is 60 kg. Now you carry 20%. Okay, what is the power needed for you to carry the 20 passenger? So at here, you must understand the total power at here. It must be the power in order to overcome the friction and also the power to carry the passenger. Without passenger, you already need this. Now with passenger, so we need extra power. Okay, do you need extra power? No, the answer is not D. Okay, so here is 22,000 kilo. Passenger, what is the power for passenger? Force times V, velocity, how fast? Oh, they tell you this one is 0.75 ms negative 1. Okay, how fast is this is the speed? Okay, here. What is your force? See this one, if the person I draw in the box, assume this is the load, this is the weight. What is your force? What is your force to carry this load? So using just now, we got do few question for this kind of question already. Correct. Wesley right now is correct. How about others, dear? Yes, correct. Here you will get 30 degree. Yes, Vashini already helped us to calculate the 30 degree. So here 30 degree, how we get? Sine angle equals to 30 over 60. So angle is 30 degree. So we get 30 degree. Once you saw triangle, actually plus minus, we know that we will need to using the tuakaso, okay? Let me have a look. Yes, power correct. Okay, you have to resolve it in order to find the force. Okay, in order to find the force. So at here, the force that we are going to use is mg sine 30 degree. This is the force. mg sine 30 degree. Okay, mg sine 30 degree. So the mass at here, you have to using the total mass. Total mass is 20%. Each of them is 60. So G is 9.81. Sine 30 degree. How fast they travel? 0.75. So this one 2000 is without. With or without. We also need this for the friction part. So if you do like this, at the end your answer is 6.4 kilowatt. This is the answer. Washini correct. Kai-chen correct. Okay, like boys and girls, since we got 2 minutes, we still got 2 minutes. We go back to question number 4. This one you do. And then the subjective one, page number 10 until page number 13. This one I will print the model answer and share in the group. The working step for page 10 to page 13, I will share in the group. Now we go back to this question and complete question number 4. Okay, we left 1 minute. Like boys and girls, we use our faster speed to complete this question. Hydraulic. In one such pump, the long approach pipe, it holds 500 kg of mass. So this one is M. When the speed of water reach, so this is your V. Kinetic energy is used to lift a small amount. Okay, so that means that kinetic energy is your input. Okay, used to live. That means that your mgh should be your output lah. Efficiency is 10%. So N equals to power output, useful output divided by power input. Okay. Times 100%. Or we here using energy. It didn't give us the time, right? We can using the energy. Any of you get the answer? Show me. Tell me. Yeah, I already give you the answer. Now I'm asking you answer. Just now I already asked you to mark down answer. Okay, here they say kinetic energy is used to live. So that means starting input is kinetic energy. So input is kinetic energy is 1 over 2 mv squared. So 1 over 500 of water, speed is 2 squared. So my answer is 1000 watt at here. This is my input. I use kinetic energy to live, okay? To live. Vowel correct. Shan correct. Then what is your output? Energy output. With a certain height. So that means my output must be mgh. Okay, my output must be mgh. So at here, efficiency is 10% equals to my output is mgh. Divided by my input is 1000 times 100%. So mgh should be 100 watt lah. M is the water. How much of water actually will be lifted up? This mass we are going to calculate. Then G is 9.81. H. Lift to 15 meter. 100. Oh, it's not watt. It's 100 joule. So mass at here, my answer is 0.68 kg. Like boys and girls, for this question, do you facing any problem? Here they say that with the speed, kinetic energy to lift the water. So that means that kinetic energy is your input energy. Then you lift your water up. But then your efficiency is very low, only 10%. So the total mass that you're able to lift confirm is very far from the 500 kg. If perfect, it will be 500 kg, but it cannot. This is only 10%. So our answer will be B. Okay, any other question? Your page number 10 until page number 13, just like I mentioned, I will print the working step for you to check by yourself. Then we will officially complete your chapter. This is chapter number 5. We complete chapter 5. Lesson number 22 is self-practice. Same things, same like normal. I will give you the model answer. So you do self-practice lah, okay? Our target is every 2 lessons we can complete 1 chapter. Okay, any question? Last chance. If no question, then you give me response. Okay, then we end our lesson right now.